All right, talking about parallel perpendicular slopes today. Parallel lines have the same slopes, so that's something that you'll need to remember. The difference between parallel lines and perpendicular lines. We'll talk about that at the beginning, do a few example problems, and then that is that. So our examples, notice there's some different forms here. We have slope-intercept form for this first one, so it already has our slopes. So what we're going to put in this row are the parallel slopes, which we wrote up at the top that those parallel slopes are the same. So it's really just find the slopes from these lines, write them down here, and then these are also going to be the parallel slopes. So the slope for this one is just simply 2. That means the parallel slope is also 2. Fairly easy, I hope. Then you come over to this type of line. So both of these are in standard form, but we are going to change them to slope-intercept form, which means we need to solve for y for both of these equations. So in order to do that, I'm going to subtract 4x on both sides. But I'm actually going to, yeah, I'll show you how I'm going to write it. It's going to disappear over here. I guess I should have written it directly under it. It doesn't matter. They just go next to each other. But I always like to put it in the y equals mx plus b form instead of putting the 2 first, because then it just looks weird. And my brain is used to seeing it like this. So my slope is going to be -4. But if we look here and we just look at the equation, we think, oh, the slope is 4. But it's not. You have to put it, like, solve for y first. All right, so this one was pretty easy because y was all by itself. This one's a little more involved because y is next to a -3. But we're going to do the same thing. We're going to subtract 2x on both sides. -3y equals -2x plus 6. So I'll give you guys a second to write that down. We did the same, and we're going to do this process lots and lots of times today. You'll get lots of practice. But you move the coefficient in front of x and the x over, and that sign needs to change. Then you want to get y all by itself. So in order to do that, you've got to divide by -3. But because of this plus sign, you must divide this by -3 as well as the this number right here, 6, needs to be divided by -3. And what ends up happening is you get y equals -2 over -3. They're both negative, so the negative cancel out. It becomes positive 2/3 x minus 2. Why is it minus 2? Because positive 6 divided by -3 is a -2. Now you have the slope that you need. Is that a little more involved than these two? Absolutely, it is. But you just have to recognize what you need to do to solve for y. So 2/3 is going to be that slope. You can circle that if it's kind of weird like mine. But yeah, since we found the slope here, you just transfer it down here. These are all the parallel slopes. But yeah, so the slopes for perpendicular lines are opposite reciprocal. We're going to do this. You have to change sign and flip it. You must do both things. So we're going to change sign. This one is going to be a negative because it starts as a +5. But then you're like, wait, how do I flip a whole number? Well, it's the same. 5 is the same as 5 over 1. So anytime you just have a whole number, you need to put 1 over that number. And that's it. For this one, it's already in a fraction, so that's nice. It goes from negative to positive, and then you flip it. All right, we have another whole number here. So it's going to be 1 over that number, but remember, if it starts as a negative, it needs to end as a positive number. So changing the sign and flipping it every time. Don't forget one of them, because if you don't do both things, then you won't have the perpendicular slope. And then this is -4. Notice I don't write -4 over 1. You don't need to do that. Because it would be, I mean, you don't look at whole numbers as over 1. It just is assumed. All right, let's move on. So these next few problems, I just pulled these straight from Delta Math. So this will be very helpful when you're going through these types of problems. And you're like, oh, I don't know how to do this. Well, I've got 3 examples that are over this section. So these are, I think these are actually multiple choice on Delta. You're just going to pick of these 4 things, but you have to determine the slope for each one first. So some of them are going to be both in standard form. So we need to figure out the slope. So what we did on that first example up here, we're going to do that a couple more times right here. We are going to solve for y. So let's add 4x on both sides. So essentially we're just moving it over, we're changing the sign. 6y equals a positive 4x plus 12. See why that happened? This just gets moved to the other side of the equal sign. y equals 2/3 x plus 2. All right, so we divided by 6 on all the things. Each side of that plus sign, both sides of the equal sign, all the things get divided by 6. All right, we're going to come do the same thing on this side. So we have one line right here. So we are going to be looking at this slope. So I'll circle it just to make it pop so we can see it. A positive 2/3 is that slope that we're looking at. And then we're going to move this 2x over to this side. 3y equals negative 2x plus 21. One of the most common mistakes I see is when we move that x over, we forget to change the sign, and then it just throws everything off. So try not to do that. Divide all the things by 3. So hopefully you're kind of seeing a pattern in the steps of what we're doing. All right, now you've got two slopes and we're going to compare them. We're going to determine parallel, perpendicular, same line, or neither by looking at the slopes. So we figure out, could they be either parallel or perpendicular first? Parallel would mean the slopes have to be the exact same. Is a positive 2/3 and a negative 2/3 the exact same thing? No, they're not. They are not the same, so we cannot say parallel. And then for perpendicular, does it look like it could be perpendicular? Well, they have different signs, but have they been flipped? No, they haven't. So you're looking for both of those things. So is it the exact same line? No, they aren't the exact same. You can obviously tell that because all the numbers are different. So it is going to just be neither. But when you look at these two lines, you can't really tell that until you change them to slope-intercept form, where you can compare their slopes and their y-intercepts to see if they're the same. All right, I'm going to pause my screen. For this one, is already in slope-intercept form, so you're not having to do this twice. But I want you guys to solve for y here because I've done it 3 times at this point, and I want to make sure that you can do it, but you're only doing it once. So solve for y to where you can get the y-intercept and the slope. All right, first thing we're going to do, we're going to add 20 on both sides, and then we get this. Then you need to divide by 16 all the way across. So you end up with something like this. So kind of check what you have. See if you have that. Or if you made a mistake, fix that mistake. Now we're comparing the two slopes. So notice I circled both of them. And you're like, okay, one's positive, one's negative. So, well, I guess first thing you look at, are they parallel? They're not because the slopes aren't the same. But one's positive, one's negative. Great. So are they flipped as well? 5/4, 4/5. Yes, they're flipped. So these are going to be perpendicular slopes. And then this was nice because you only have to solve for y on one of them. All right, let's go to the next page. Okay, this one is a little tricky, and I'll show you why. So well, it's really not that bad. We're going to move this over. It's going to be positive 5x minus 5. So I just changed the sign of that, moved it over here, positive 5x minus 5. It was negative here, now it's positive. For this one, we're going to move the 20x over. 4y equals positive 20x minus 20. Divide by 4 all along. All right, look what we have going on here. So I did that kind of quickly, but we notice that the slopes are the same, and this is what can be tricky. Make sure you're not just finding the slopes, because you realize these slopes are the same. If you put parallel, you would be wrong on this one, because yeah, they are the exact same line. The definition of parallel is 2 lines that have the same slope. This is just one line, because if they have the same y-intercept, they are the same. So just make sure you're paying attention to that. Because if they had the same slope but a different y-intercept, they could be anything, but if they're not the same, it would just be parallel. Okay? These, in particular, are the exact same line. Yeah, just pay attention to that. Couple more. All right, the process, this is kind of a lot of steps. None of these steps are overly challenging, but this is, a lot of steps. So as you go through them, make sure you do it carefully, because it's frustrating to get all the way through it and then realize, oh, I messed up. I'm going to rewrite this equation over here. 3x plus 2y equals 4. We need to realize a few things. We are looking for a line that passes through this point, but it has to be perpendicular. So we are going to need to find the slope of this line first, then change the slope to make it perpendicular, and then do the process we did yesterday by solving for that equation, solving for your b by plugging in the point and the slope. All right, but I'll go through it step by step. So we're going to subtract 3x on both sides. So that same process that we've done all day today. 2y comes down. This becomes negative 3x plus 4. So notice I just moved this to the other side of the equation, changed the sign on the coefficient in front of x. Divide all the things by 2. Y equals negative 3 halves x plus 2. Great, so we have this equation. It is in the right form to where we can figure out the slope. So our slope is negative 3 halves, but it's not the slope we want. We want the perpendicular slope. So we want to change that to the perpendicular slope. So we want positive 2/3. Yeah, so this symbol just means perpendicular. So this is the slope we're going to use. This one right here. This is the original slope from this one. We're going to use the perpendicular slope. So our perpendicular slope is 2/3, or I don't know why I wrote it like that. I said it and then wrote crazy things. And then x and y is our point. So now we have our m, our x, our y. We need to plug it into y equals mx plus b form. This is what we did yesterday. Same process that we did yesterday. So the new stuff is here up to this point, and then this is everything we learned yesterday. Negative 1 is my y. 2/3 is my x. No, that's wrong. 2/3 is my m. 6 is my x. So y equals mx plus b. You're solving for b. 2/3 times 6 is 4. How do I know that? Because 12 times 6, or 6 times 2 is 12. There we go. Divided by 3 is 4. If you want to check your answer, your calculator will also do this for you. 2/3 times 6, and then you can check, make sure you did it correctly in your head. Subtract 4 on both sides. Negative 5 equals b. And then you have all the things that you need to type in your equation into delta. Y equals 2/3 x minus 5. All right, so for this one, we've got parallel. So this is parallel. Notice the difference. This one's perpendicular, this one's parallel. Please don't get those mixed up, because if that's really the main thing I'm talking about. Of if you get that mixed up, it's going to be wrong. You'll be sad. You'll have to start over. So let's solve for y first. Negative 2y equals negative 5x plus 2. Divide by negative 2. All right, we've done this many times, so I'm going to go fairly quickly on this part. So my slope is 5 halves. It is parallel. Don't change it to perpendicular. I can't tell you how many times I see this where it says parallel, but people change it to perpendicular because they're just not reading and paying attention and trying to go quick. And then it ends up messing it up. And so now we plug these things in. We have our slope that does not change. We have our x, our y. Y equals mx plus b. We're going to multiply these. You're going to get negative 10. When you multiply 5 times negative 4, you get negative 20. Cut that in half, you get negative 10. Then we add 10 on both sides. So b ends up being 4. So y equals 5 halves x plus 4. All right, I went fairly quickly on this one. It's the same process that we did yesterday. So if you're struggling with that, make sure you have completed that assignment from yesterday before you move on to today's. But the difference is just parallel versus perpendicular. Please read it, because these can get really frustrating if you're like, oh my gosh, I thought it said perpendicular and it said parallel.